Are you interested in automating security tests within your software lifecycle? Let's see how we can do this using the knowledge that you've gained in writing Burp macros and Burp plugins. It's possible for DevOps teams to easily inject security-related tasks into their development process. Now, the end result is going to increase the security of your code much earlier in the lifecycle, which ultimately will mean a higher quality of code that you deploy to production. Let's talk about some of the tasks that you could add to your build process. So whether you use Jenkins or Maven or some other build process, you can add the following security-related tasks. You could add scripts that invoke your static code scanning. You might be using something like checkmarks or HP Fortify, for example. You could also add scripts to invoke your dynamic code scanning. Now, this is really the focus of this particular module and what you'll see me doing inside of the demo. This is where you're going to call Burp to perform your dynamic scanning. Now, once Burp identifies those items, you could generate JIRA tickets programmatically, and then you could use something like ThreadFix to track the progress of those tickets. So using some community code from VMware, we're going to compile and execute a REST JSON endpoint for Burp. Now this endpoint is going to allow us to access the scanner, spider, proxy, and other features of the Burp Suite toolset. So in order to get started, we first need to download the source code from GitHub. You're going to use the following git clone command to the URL shown on the screen. The name of this GitHub project is Burp REST API. Now, following the README instructions available on the GitHub page, you will be asked to either compile or run the executable using the Gradle provided script. Now, prior to running that script, please make sure that you identify a target application. Now, if you decide that you would like to actually compile the code, you're going to need to modify the test scripts, and you're going to have to set up a site that runs over both HTTP as well as HTTPS. Now in the demo, you'll see that I used Tomcat 7, and when I did compile the code, I did configure a self-signed certificate inside of Tomcat. You don't have to compile the code. You can run the executable just as it's made available to you from the GitHub repository. So located directly under the Burp REST API folder is a Gradle script called Gradle W. Now if you own Burp Pro, you're instructed to put your Burp Pro jar file in a lib folder directory that you'll need to create prior to kicking off the script. Now realize that you don't have to use Burp Pro to run this. If you choose to use the free edition, you'll just need to add an additional parameter. Should you choose to compile the code, please go into the Burp Client IT class and modify the target host to reflect the particular target that you're going to compile your code against. These test cases will then be able to pass successfully. Now, once you've compiled the code, there's a very nice Swagger UI that is made available to you for testing out your REST API endpoints. So some of you might be thinking, well, what is Swagger? So Swagger is a framework of API developer tools that helps programmers to work more easily with API calls throughout their software lifecycle. So once you're executing the Gradle script, you're going to be able to do the following. Browse to localhost 8090. This is where the Swagger UI will be running. You're going to see a listing that reveals all of the available Burp REST API calls. So from that listing, you're going to be allowed to test all of the API calls available and look at the expected responses. So this is quite handy when you're initially setting up how you want to automate this process. So now, by adding macros to your target application, you can more easily recover from errors that may occur, say, from spidering or scanning. By adding extensions inside of Burp prior to your script kickoff, you can more easily customize your findings by, say, adding more injection points or scanning for the presence of interesting HTTP headers, as we saw in some of the plugin exercises and demos. And now, with the help of this REST API, you can run Burp in a headless mode, allowing for a much easier automation process that can be incorporated into products like Jenkins. So let's see how all of these components work together. In this demo, we're going to see how we can incorporate security into our DevOps process. We're going to be using the Burp REST API. We're going to run that against a target application. Then we're going to take a look at the listing of REST calls that we have available in the Swagger UI and invoke those Burp REST calls accordingly and take a look at the results that we get. This is the demo for incorporating the Burp REST API into your DevOps process. After downloading the GitHub repo, you'll notice that there is a script by the name of Gradle W. So we're going to be running that. You have the choice of either building the code first and then executing the script, or you can just go ahead and execute the script. But prior to that, you do need to pick a target application. Now what I've done is I've fired up my Tomcat. I'm running on port 8888. So now what I'm going to do is I'm going to actually close Burp. Now I'm going to run this script with a few options. So here you see the command, the Gradle W boot run. I'm going to turn headless off. Now normally you would not do this. As you're working with an API, you would leave headless as true. So that just means the GUI would not come up for Burp. But in this case, I want to actually see it. Also, you'll notice that I'm going to use the free edition here. Now, if you wanted to use the Pro edition, you would just leave this last argument off that I have in quotes. So let's go ahead and run this. So at this point, you see that Burp does start up. I'm going to delete my temporary files, go ahead and start it. So once I have this running, and you'll notice that it'll stop at building 83% and be running this boot run. From there, you can open up a browser and go to localhost 8090 swaggerui.html #. Now what you're going to notice is a listing of REST API calls that you can make. Of course, you would be running these in headless mode, but this GUI is very nice because it allows you to see what types of activities you have available. So for instance, we can take a look here at the Burp configuration that's being used. So first you're going to need to call this put to put the URL that you want to scan in scope. So the order is to call put first, click try it out. You should get a 200. Then you can select this get. Put the same URL in there, click try it out, and you should now have that URL in scope. So you've got to set your scope up first, just like we do in the GUI, in order to perform any of the other features of Burp. So now that you have your scope set, let's go ahead and run Spider. I've got my URL set. I'm going to go ahead and click try it out, and I do get a response of 200. So this post is where you would run your active scanner to then identify all of your issues. Let's take a look at our proxy history. And here we can see an array of messages that gives us our proxy history. Once you identify your issues, you can also generate a Burp report. Just like the GUI, you can specify whether you would like it in HTML or XML. So hopefully this was a good overview of how this very nice Burp REST API could be used in your DevOps software lifecycle in order to automate the tasks surrounding Burp scanning.